The mysterious compound problem-based learning activity, which I created for my chemistry students, is an example of my desire to take the theoretical knowledge I had gained about constructivism and put it into practice. In this PBL, my students are answering the driving question: how do we, as forensic chemists, use experimental data to determine the identity of unknown substances found on crime scenes? I chose this topic because while we can do lots of experiments in our lab, we cannot or do not have the equipment necessary to do high-level combustion or elemental analysis. However, this particular PBL uses quite sophisticated online simulations and virtual labs in which students build the knowledge about each different type of chemical analysis. They use this simulator to learn about combustion analysis. They go through a series of online tutorials and virtual labs. They also conduct a wet lab in our own classroom that reinforces the knowledge that they've gained about chemical analysis, all the while keeping what they've learned and recording it in a learning log. The learning log not only serves as a place to record the information and the knowledge they're building, but also to answer key questions that I pose as students move through the activities. Consistent with inquiry-driven instruction and constructivist learning theories, a hook is provided at the beginning of the activity, an entry event in which students are presented with a mystery to solve. Playing the role of forensic chemists, it becomes their job to determine if the chemical compound they've been handed is in fact Tabin, a chemical warfare agent that the FBI suspects was going to be used in a terror attack. Students are then told that they are going to engage in a series of labs, investigations, and online simulations that will allow them to build the knowledge they need to solve its formula. The culminating event is a presentation in which the students present their calculations and results defending their chemical formula. When designing this PBL and deciding what types of learning activities to include, I went back to constructivist learning theories, which advise 4 types of supports that are needed for students as they progress through constructivist activities. Conceptual, metacognitive, procedural, and strategic supports and scaffolds were put in place to ensure that students had everything they needed to get to the end goal of solving the chemical formula. Throughout this process, I was amazed at how engaged my students were the entire time. Returning back to the driving question on all of my documents and all of my activities, having a learning log put in place, students were really able to monitor, engage where they were in this process, how far they had come, and where they still needed to go to get to the end. Feedback from my students was tremendous. In fact, they were hoping that I could put more of these types of activities in place the following semester.